Today we're going to look at finding what is called the greatest common factor and look at how we can use the zero product rule to help us solve equations with polynomials. But first, the GCF, or greatest common factor. This is the largest factor that we can divide each term in the polynomial by with no remainder. The best way to think of it is finding the GCF of the number and the smallest exponents on all shared variables. So for example, if we have 5x to the 5th, y to the 3rd z, minus 15x cubed, y to the 5th, plus 20x squared, y to the 4th. If I look just at the numbers of 5, 15, and 20, the biggest thing I can divide them all by is 5. They also all share an x. We'll take the lowest exponent that shows up on an x, which is squared. And they also all have a y. And we'll take the lowest exponent that shows up on a y, which is cubed. Note, sometimes this is going to be a 1. Don't forget, if it's not written, the exponent is a 1. Now, one term does have a z, but they don't all have a z. So we have to stop here, and we'll say the greatest common factor of this trinomial is 5x squared y cubed. Once we've identified that greatest common factor, we can actually factor it out by dividing each term by that greatest common factor. What we're really doing here is reverse distributing. Here's my original polynomial. We said the greatest common factor was 5x squared y cubed, so we can think about dividing each term by 5x squared y cubed. All the way across, dividing by 5x squared y cubed, and dividing by 5x squared y cubed. And what we're really doing is reverse distributing. We're pulling that 5x squared y cubed out in front of the parentheses to see what's left inside the parentheses. On the first terms, the 5's divide out. X to the 5th divided by x squared is x cubed. Y to the 3rd divided by y third, that divides out completely, and we're left with a z. On the second term, negative 15 divided by 5 is negative 3. Subtracting the exponents on x, 3 minus 2 is 1. Subtracting the exponents on y, 5 minus 3 is 2. Plus 20 divided by 5 is 4. The x squareds are gone when they divide out. And y to the 4th minus y cubed is y to the 1st. And now we have factored out the greatest common factor of 5x squared y cubed and ended up with this product, 5x squared y cubed times x cubed z minus 3xy squared plus 4y. As I said earlier, what we're really doing is reverse distributing. We're undistributing that 5x squared y cubed, that GCF, to see what was left. This idea of factoring out the greatest common factor is the first step of every factoring problem. And people forget this first step all the time. Every test, I'll see somebody who will tell me more about factoring out a polynomial without checking for the greatest common factor first. This is the most important first step. It's quite simple, but it's often forgotten. So we're going to spend a whole day on factoring out that greatest common factor. So I've got two examples here. 4x to the 5th plus 6x to the 4th minus 2x squared. 4, 6, and 2 are all divisible by 2. They also all have an x. The lowest exponent is squared, so we're going to factor out a GCF of 2x squared. So I think about dividing each term by 2x squared to see what is left. On the first term, 4 divided by 2 is 2. Subtracting the exponents on x, 5 minus 2 is 3. Plus 6 divided by 2 is 3. Subtracting the exponents on x's, 4 minus 2 is 2. minus 2 divided by 2 is 1. Be very careful when it divides out completely. There is a 1 left. Anything divided by itself is 1, not 0. It does not disappear. And x squared divided by x squared, all the x's divide out. And so now we have factored out our greatest common factor. This next example, we have 6ab squared plus 6a squared b plus 12ab. You can see the numbers are all divisible by 6. They also all have an a, at least a to the first. They also all have a b, at least b to the first, but no more than that. So what's left when we divide by 6ab on each and every term? Well, in the first term, 6 divided by 6 is 1. A divided by a is 1. B squared divided by b, there's something left over, a b. Plus, the 6's will divide out, the b's will divide out. We're left with a single a when a squared is divided by a. And then the a's and b's divide out. Plus 12 divided by 6 is 2. And after factoring out the greatest common factor, we're left with 6ab times b plus a plus 2. There's a special rule in algebra called the zero product rule that allows us to use factoring to help us solve problems. But first, to set it up, consider the equation 5x equals 0. It's clear in this equation that the x has to equal 0 because we know 0 times anything is 0. So it must be 5 times 0 equals 0. But what if we didn't have a number? What if it was just a times b equals 0? We still know that one of them has to be 0 because anything times 0 is 0. We don't know if it's a or b, but either a is 0 or b is 0. This is the zero product rule, which we can use once the GCF is factored out. Consider 5x times x plus 2. We're really multiplying two things together. The 5x times the x plus 2. One of those has to be 0. Either the 5x equals 0 or the x plus 2 equals 0. First equation solves quickly by dividing both sides by 5. X equals 0. Or the second equation solves quickly by subtracting 2 from both sides. X equals negative 2. Two possible solutions for x in this equation. Both of them are correct. In fact, you need both answers. X equals 0 or negative 2. How about this problem? 4x squared plus 6x equals 0. Notice the difference here is the terms are added together instead of factors multiplied together. We can't set the pieces equal to 0 unless we have factors. So let's factor this problem. We know how to factor out the GCF. 4 and 6 have a GCF of 2. They both have at least x in common. When we factor 2x out of the first term, 4 divided by 2 is 2. X squared divide out an x is x. Plus 6 divided by 2 is 3. And the x's are factored out. Now that it's factored, we can set each factor equal to 0. Either 2x equals 0 or the 2x plus 3 factor equals 0. The first equation we solve by dividing by 2, so x is equal to 2. The second equation is a two-step equation. We subtract 3. 2x equals negative 3. And divide by 2, I'm running out of space, but the other option for x is negative 3 halves. Sorry, that's kind of hard to read there. Negative 3 halves. So the two possible answers for this equation are 2 and negative 3 halves. Whenever we have this equal sign, we are able to solve our equations. Be careful not to confuse the first part where we just factored out the GCF and we were done. There was no equals 0, so we couldn't solve those. We need an equals to something in order to solve with the zero product rule. But another important point is with the zero product rule, the equation must equal 0. It's not the 7 product rule. It's the 0 product rule. So whenever we have polynomials, we must be equal to 0 before we can solve the problem. If my problem says 4x squared equals 8x, I need to do some work to make it first equal to 0 before I can solve it. Well, we can make it equal to 0 by subtracting everything out of the right side. Subtract 8x, and now we have 4x squared minus 8x equals 0. And now I can solve this problem. To use the zero product rule, we need factors, so we'll factor out the GCF of 4x. When we do, we're left with an x minus 8 divided by 4 is 2. Equals 0. And now we can set each factor equal to 0. 4x equals 0, and x minus 2 equals 0. Quickly solve by dividing the first equation by 4 to get x equals 0. Add 2 to the second equation to get x equals 2. Our two possible answers here are 0 and 2. So the zero product rule, it must be equal to 0. Factor it and set each factor equal to 0. To do that, we looked at that greatest common factor. So take a look at the homework assignment tonight. Practice with that greatest common factor, factoring it out, and then how we can use that with the zero product rule to actually solve polynomial equations. Good luck on your homework, and let your instructor know if you have any questions.